Hello everyone, in this video we'll be solving the question number 628, which is the maximum product of three numbers. The question is marked easy. The question is very easy to understand as well. I have found few examples, so as a result, after understanding the question, we'll move to those examples, we'll form two to three conclusions, and as a result, we can build our approach. Okay, so let's first understand the question and then understand constraints, then understand our examples, form few conclusions, and then we will join them to build our approach. Okay, so let's start by understanding what the question wants to say. Okay, so we are given an integer array nums, okay, and we need to find three numbers whose product is maximum and return the maximum product. Okay, so let's first jot down what things are given. We are given an integer array. Its variable name is nums, and we need to find three elements which will yield us maximum product. Okay, so let's first take one simple example and then understand what the question really wants to say. We have one integer array nums as 1, 2, 3, and 4. Okay, we need to select three elements. How many triplets can be formed? 1, 2, 3. 1, 2, 4. 1, 3, 4, and finally 2, 3, 4. And then we will find the product, which is 2 star 3 star 4, which is 1 star 3 star 4, which is 1 star 2 star 4, and 1 star 2 star 3, which is equal to 6. In this case it will be 8, in this case 12, and 24. So we have found that this 24 is the maximum. 24 is max, so we will return 24. Okay, that's one of that. But we are also given that the nums of I can be in the range of -1000 to minus positive 1000. Okay, so let's first move these two segments. What does this mean is that nums I can be negative. Okay, let's take one example to understand what does it want to say, or how does this make this question a little bit trickier. Okay, let's take one example like, okay, this one. The array is -1, -2, 3, 4, 5, and 5. We want maximum product. So why don't I choose top 3 or the max 3 elements? Here in this case it will be 4, 5, 5. So our answer will be 4 star 5 star 5, which is nothing but 100. Okay, if we select any other 3, we can see that no one can surpass the mark of 100. So we have one conclusion that we select the maximum one. In this case, maximum one. And naming conventions can be different as per each user, each developer. This is max 1, this is max 2, and this is max 3. Max 3 is the biggest one. Max 2 is just the next one to it, the second biggest, and the next one is the third biggest. Okay, or let's rename it to maximum. So here also it will be okay. So we'll select top three, max one, max two, max three, max one, biggest, max two, second biggest, and max three, third biggest. Okay, this is a one conclusion number one, that this can be one possibility. And let's select all this and move a little this side. Okay. Let's take one more example in which there will be a different scenario. Hmm, Here terms is minus 10, minus 5, minus 4, 2, 3, and 4. The first instinct will be top 3, which will be 2, 3, 4, and the answer would be 2 star 3 star 4, which is nothing but 24. But this is incorrect. This is wrong. Why? Because if you see using minus 5, minus 10, minus 5, and 4, it will give us a better answer. Minus 10 star minus 5 star 4 will give, this will give us 50, and this will 200. So answer will be 200. What if we select these three? Minus into minus will be positive, and minus 1 second will give us a negative answer. So selecting three negatives in this case is not optimal. What if we select minus 10 minus 5 with 3? But why select a smaller number when we have a bigger number? Okay, so we have one more conclusion here, that is minimum 1, minimum 2, and then maximum 1. This is minimum 1, minimum 2, and maximum 1. Okay, so we have found one conclusion, that is bottom 2 top 1, which is min 1, min 2, max 1. Min 1 is the smallest, min 2 is second smallest, and max 1 is the biggest. Okay, these are conclusions, so let's make it clear. And then we move it this side, and this arrow also needs to be shifted. Okay, let's take one more example. Which is, let's give it a bend so that it will look better. Okay, so the array is minus 10, minus 5, 5, 20, 30. So our instinct will be top 3, which is 5, 20, 30. Answer would be 3000. Next will be bottom 2, top 1, which is minus 10, minus 5, and 30. The answer would be, I guess, minus 10 into minus 5 will be 50. 50 into 30 is 1500. Okay. And you might be thinking that here we have minus 5, minus 10, whose magnitude is bigger than this 5. So why don't we choose a minus 10? But selecting a single negative number will make the whole output negative. If we were to select two negatives, it would make the negative positive, and then we will take the top, the biggest one. Here in this case 30, which will become 1500. Minus 10, minus 5 and 30. So the answer will be 1500. But even though this 5 is less than 10 minus 10 in terms of magnitude, it is yielding us a better, what you can say, output. So selecting the top 3 sometimes is also better, even though there is a gap in magnitude. Okay, so we have formed two conclusion is that either take top 3 or bottom 2, and then let's we select the maximum. Okay, let's now jump to, oh no, let's first create one dry run, or what you can say, approach. First is declare max 1, max 2, max 3 to int min. Second is declare min 1, min 2 to int max. Why? Because when we do the maximum function over this or any of these term with any other term, the maximum will be taken. If we declare it with integer maximum, there is no another possible value which is greater than integer maximum. So to always get a bigger value or the maximum value, we initialize this max 1, max 2 and max 3 with integer min. Okay, and likewise for min, if we want to find minimum, we will initialize with integer max so that we get the minimum value. If we initialize them with integer minimum, there is no another number which is smaller than integer minimum. Okay, after finding, we iterate the elements and check if, now we will use the approach of finding the top 3 maximum, and we will use the approach of finding the two smallest. If let's find maximum scenario, and also we will use 5 minimum scenarios. Okay, and then do a maximum of, what you can say, max 1 star, max 2 star, max 3, and min 1 star, min 2 star, max 1. Okay, okay, let's take one more example which contains all the negative numbers. Nums, nums equals to minus 1, minus 2, minus 5, minus 4, minus 3. So what should be our number? Let's first make it easy to understand. So we'll shift this to this side. minus 2 minus 1. Top 3 will be minus 3 minus 2 minus 1, which will give us minus 6. Bottom 2, top 1, minus 5 minus 4 minus 1 minus 20. Then for file information, minus 6 is greater than minus 20 because minus 20, then there will be few numbers, and then there will be few minus 6, then there will be few numbers, and then 0, and then the positive numbers. Okay, so as a result, minus 6 is greater than minus 20. Okay, so in this case also this top 3 will work. Okay, so let's move to the implementation part. So yeah, let's first initialize max 1, max 2, max 3, min 1, min 2. Okay, int max 1 equals to integer min, max 2 equals to integer min, max 3 equals to integer min, int min 1 equals to integer max, min 2 equals to integer max. Okay, now what we will do is iterate the elements. We will use for each loop, for auto and val nums. Val greater than max 1 will update max 3 with the value of max 2, max 2 with the value of max 1, and max 1 equals to val. Okay, if now else if this val is not greater than max 1 but it is greater than max 2, so what will happen? We will update the value of max 3 with max 2, and we will update the value of max 2 with 1. And if value is not small greater than max 1 or max 2 but it is greater than max 3, so we will update the value of max 3 with 1. Okay, this is for the max scenarios. Let's move to the min scenarios. If val or value is less than minimum 1, then what we do is update the value of minimum 2 with minimum 1, and update the value of minimum 1 with 1. Okay, else if value is not smaller than minimum 1 but it is smaller than minimum 2, so we will update the value of minimum 2 with val. Okay, now we will return the maximum, which is return max of x1 star max 2 star max 3, which is the top 3, and min 1 star min 2 star max 1, which is the bottom 3, bottom 2 and top 1. Let's first add comments over here. Let's first check whether it is valid or invalid. Okay, all test cases are passing. So value is greater than maximum 1. So what we do is update max 3 with max 2. So as a result, the value before the value of max 2 is lost, the value of max 2 is given to max 3. update next to with and update next to. Similarly, L is smaller, sorry, not smaller, not greater than x1, yet bigger than x2. So we will first update max3 with max2 and update max2. Now here what happened is not greater than max1 and max2 but bigger than max3. Update max3. Okay. Here where is smaller than minimum, update with minimum and update minimum. There is not smaller than minimum but smaller than min2, update min2. Okay, let's submit it. Is it good? Okay, so the solution is correct. So I hope you guys understood why we select top 3 and one more which is bottom 2 and top 1. It is valid for all the cases because of we select bottom 2 and top 1 just because the constraints include the negative numbers as well, not just positive numbers but negative numbers as well. So we need to consider negative numbers as well because the product of two negative numbers is a positive, and there may be a chance that two large magnitude numbers but are negative are also present. So using that will be beneficial. Okay, so I hope you guys understood it, and if you have any doubt or anything regarding, you let me know in the comments. Thank you.